So what I want to talk to you about today is fairness and how can algorithms be fair, and how do we figure out whether an algorithm is fair or not. And in order to do that, I would like to start asking you, what do you consider fair? So take a moment to think about it. What is your definition of fair? And this is what Webster's dictionary has to say about fair. Impartial, honest, free from self-interest, prejudice, or favoritism. And now I want to transfer this concept to the world of machine learning and AI, and to the algorithmic systems that have already been deployed and are used in our everyday lives. So let's take a look at how this kind of concept maybe doesn't work out well. Okay, so let's start. What about the impact on the environment that our lovely machine learning algorithms have? They take so much computing resources that they use up more energy and emit as much carbon as 5 cars in a whole lifetime. So something to consider when we're training our models. This goes especially for us NLP people. Another concept that people don't often see very often, the labor conditions. So we have huge data sets in machine learning, and these data sets have to be labeled. Who's doing the labeling? This article in The Atlantic, I recommend people to take a look and read it. It doesn't paint a nice picture of the kind of working conditions that people have, the ones who are tagging our massive data sets. And another impact that we don't see are algorithms which actually do their job very, very well. These are scheduling algorithms, and they're meant to optimize staffing decisions so that cafe and restaurant owners hire their waiters and their staff only when they need them. And what these algorithms have done is stopped treating people like humans, and they just treat them like objects and optimize them, leaving them with totally unpredictable schedules and very little downtime. Okay, and some algorithms are just plain horrid, like this app that was put up last year, which takes any photo. Actually, it only works for women. It takes a photo of a woman and totally undresses her. And that app received so much negative feedback, the person took it down. But now it's back, and it's back on Telegram. So, and then there are the things, of course, oops, we forgot that you existed. So here's App's health app when it first came out, with tons of metrics. They forgot to help women track their menstrual cycle. Okay. And once you get started, the list goes on and on and on. computer vision that doesn't work for people of color, hiring algorithms which discriminate against women, Amazon, which doesn't deliver to Black neighborhoods, a grading algorithm which actually marks children from disadvantaged neighborhoods. It reduces their grades. So once you start looking, it becomes quite depressing because it doesn't all fit in one page. I could just keep going on and on. So there is really a problem here. So, oh no, what shall we do? I'm not the only one, of course, who's seen that there are lots of things that are going wrong with algorithms. So let's bring in some ethics guidelines. And now we've seen in the last 2 years an explosion of ethics guidelines, some coming from international organizations like the OECD, UNESCO, UNICEF. The EU has set up its own ethics guidelines and put out a white paper on artificial intelligence. And of course, the big tech companies have also started setting up their own ethics committees. In the case of Google, that didn't work out very well and was closed 1 week after it came out. And then we have all the tech companies which joined forces and created the partnership on AI. So we have actually a huge body of work talking about ethics in AI, how we should or should not do things. So at this point, I just would invite you to, those of you who've seen some of these guidelines, think about it. What do you think of them? How do you like them? Because I, of course, am very opinionated. And I say, yeah, nice, but let's talk when these guidelines become binding. So we're back to our problem. Oh no, we have guidelines, but nobody is enforcing them. What else can we do? And ta-da, statistics. Rescue. But if you're going to do statistics, well, you have to measure something. So, well, fair is too broad and vague. Let's take a look at unfair. Unfair is the same as biased, right? So what's your definition of biased? Did somebody want to say something? No. Okay, so let's take a look. What is bias? So bias actually has many, many meanings. And I've listed 2 of them here. One is a meaning that we tend to use in everyday language, and it pretty much means prejudice. That you favor one group or person over someone else. But actually, bias also has a meaning in statistics. And that meaning is it's the how far off you are when you make an estimate from the true value. Okay, so the question is, what's the true value? And the other question is, what happens when you bring a new vision of bias, which is this thing called prejudice, into a field which already calls bias something else? Well, it creates some confusion. In addition, there are many, many, many different kinds of bias that you can have. You can have societal bias, confirmation bias, in-group bias, automation bias, temporal bias, and there are biases that actually are part of your statistical bag of tools. So omitted variable bias, sampling bias, representation bias, measurement bias, evaluation bias, and the list goes on. So what can we do with all of this? How do you detect it? How do you measure it? So the statisticians would say you first check the quality of your data, which is great. It's nice. It can work when you have, a relatively small data set. But when you're dealing with terabytes and terabytes of data, it becomes hard for a human being to grasp. And so actually, what happens is that bias is something we can usually only detect when we see the effect, when we see how the model behaves and what its impact is. Okay, so let's take a look. And now I want to get away from theory to start actually looking at an example. So let's say you have a model. This model is supposed to classify people into low risk or high risk. So you can think of this as, for example, people applying for a loan. You can have people who are true low risk candidates, so that if you lend them money, they are very likely to repay you. And you can have high risk candidates, people that if you lend them money are highly likely to default. So you throw in some data and your model does something with it and then spits out a prediction. Low risk, high risk. And now you want to figure out, is your model fair? So when we talk about a model being fair, really we've split up the demographic, so the group of people, into a privileged group and an underprivileged group. Or you can say a protected group and an unprotected group. And you want to compare how this model treats these two groups of people. Okay. So now we need to think, what does it mean for the model to be fair to the protected group versus the unprotected group? All right. Did anybody notice that we went on a journey from fairness to unfairness to bias and back to fairness? So here we are again. Now we're trying to measure fairness in order to detect bias, which is supposed to tell us whether our model is fair or not. So here's a fairness metric. Uh-oh. There's more than one. There are actually at least 21 different definitions of fairness, and those apply to groups, then you can also look at fairness at an individual level, and you can also have fairness at an intersectional level. But let's just start with some of these definitions of fairness. Okay, one possibility, this is called predictive parity, is that the proportion of correctly predicted high risks is the same regardless of the demographic. So if you belong to the protected group, the proportion of people who are predicted to be high risk out of all the people who are high risk is the same as if you belong to an unprotected group. How do you like this as a definition of fairness? Next. This one is called equalized odds, and it says if you're truly a high risk, then the percentage of people who get a false prediction of low risk is the same whether you belong to the protected group or not. And if you're truly a low risk, then the percentage of people that the model claims to be high risk is the same regardless of which group you belong to. All right. So now my question to you, and I invite you to put up your hand, is to tell me which one do you think is fair? Do you prefer the equalized odds? Or do you prefer hold on a sec. How do you go backwards? There. Okay, there we are. Do you prefer predictive parity? Or do you prefer equalized odds? I see here Gabriele.
Yes, correct. The predictive parity would be more fair, in my opinion, only in my opinion.
Great. Okay. Annalisa?
In my opinion, like, I think this is all about predicting correctly, right? So probably none of them, because you could predict correctly, but there is some bias already in the data. No.
Okay. Does anybody else have an opinion?
For example, what I see here is the definition of demographic it may also change. So there is always going to be a definition of demographic in which it's not, how to say, evenly distributed, in my opinion. So it makes it hard.
I actually wanted to ask about that in this situation of data, like in this data, high risk and low risk, what did it exactly mean when you said it should be equal on the all groups? What does this group exactly mean to you?
Okay, so when we're talking about algorithms being fair, we usually have in mind a group or several groups which are normally disadvantaged. Okay, if you look at the algorithms that I gave as examples, for example, the hiring algorithm, which hires more men than women. So who's the group that's at a disadvantage? It's the women. Computer vision software that sees white people, but it doesn't see black people. So who's disadvantaged here? It's people of color who are disadvantaged. Okay, so when we want our algorithm to be fair, actually, it's a very good question. We have to look and see who is at risk of being hurt by our algorithm. And then we compare what happens to these people who are at risk of being hurt to the people for whom the algorithm actually works quite well. Okay, Karina?
Hi. Yeah, I just wanted to say that sometimes it's not enough for disadvantaged groups to or unprotected or unprivileged, however they are called, to just be treated in the same manner. Some like what we do in law, you have this affirmative action, actually trying to make or increase the fairness by treating them unequal, because you say unequal should be treated unequally. So I'm not sure if this applies here as well. And then also, I think the problem is that many times you cannot generalize, and it depends on the individual situation of the case. So depending, because I don't think that for a risk score at the bank, for example, for giving a loan, in the end you need to do a individualized situation analysis, and it shouldn't go back to the demographic as such.
Good point. Anyone else?
So yes, what I totally agree with what Karina said now. I think also to get rid of the false positives or focus on not on the predictive parity, but the other one is more fair in the sense of the algorithm cleanness, but as for a society, maybe the predictive parity is more necessary to compensate for the inequalities, more or less what Karina very clearly explained.
But I think with the model, it more depends on who is, like what we are discussing before, who is asking for the fairness. If the bank is asking, bank wants the fair. I mean, if it's not a global fairness, so for the bank it should be fair that they want to count the high risk people. But for the customer, it's fair that they want to know that okay, everyone should get the like equal portion of high risk and the low risk people. So I think it more depends on also the model who is going to like for whom you are going to model the data, I think.
Okay. Karina, you still have your hand up?
Sorry, that was by accident.
Oh,
but
okay.
yeah, but for the affirmative action, it's true, it's something that the bank wouldn't usually consider. So I chose a bad example, but I mean, that's what states do sometimes with quota or obliging certain companies to comply with certain standards of having a proportionate number of people with disabilities and so on. But for the bank, for the loan, I think it was a better example, yeah.
Well, I think it's actually a good example, and you've all brought important points. The question is, so who's writing the algorithms? Who's coding?
Higher.
How are these people supposed to implement these ideas? Right? So if I'm sitting here and I'm trying to create a machine learning model because that's my job, and people told me, okay, code it and make it fair. Well, I have to measure fairness somehow. So how am I going to measure it? Do you see what I'm getting at?
Yes.
Okay, so there is a problem. The problem is at a societal level, but we've been asked to create a model. This model is supposed to take in data about people and predict should we lend them money or not. Now, in addition, I've been required to make sure that this model is fair. And so while the whole discussion all around is very useful and nice, I, as the machine learning engineer, am saying, give me a number, give me a formula, something I can work with here. So what should it be? Predictive parity? Equalized odds? Both? None? Something else? And the problem that we run into is this one. What happens when the prevalence of high risk is greater for one group than for another? So let's say, again, with the bank example, that you're comparing men to women, and your historical data shows that women are a higher risk group than men. So the percentage of default in the female demographic is higher than the percentage of default in the male demographic. Do you know what happens to our two definitions of fair? Well, it turns out you can't have it both ways. You can either have equalized odds, or you can have predictive parity. You can't have both. This unfortunately holds for a lot of the definitions of fairness. A lot of our definitions of fairness actually are mutually exclusive. So you can either have predictive parity or you can have equalized odds. But you cannot have both. And now I want to move away from the theoretical example, and I want to come to a real example that was very hotly debated. Do you guys know what it is? So who has seen this one before? Karina. Yes. So before I tell you about it, what do you think? Who's right? Let me just give you a little overview for those of you who have not seen this example before. one place where machine learning models are actually heavily in use, at least in the US, is in predicting recidivism among criminals in order to decide whether they should be released or not, or in order to decide what kind of a jail sentence to give them. And Compass is one very popular predictive model for this. And in 2016, ProPublica published an article indicating that the predictions of this model were biased. Okay.
And for how many years they were already using it?
Sorry?
For how many years they were already using it? Like before 2016?
I think actually some version of it had already been been in use since 1998. Yeah. So let me give you a little bit more information about this debate. If you want to look it up for yourself later, I have here the links to the article by ProPublica and a good explanation of what the problem is about. So if you look at it from the predictive parity point of view, North Point, which is the company that produced Compass, says, hey, our algorithm is fair. Because if you look within each risk category, so their model split people up into high-risk reoffenders and low-risk reoffenders, then the proportion of defendants who actually then go and reoffend is the same regardless of whether we're talking about a black or a white offender. Okay? So just to make it concrete, we can say within the high-risk category, about 60% of white defendants reoffended, and about 61% of black defendants actually reoffended. Does that sound fair to you? Would you expect anything less from a model?
I mean, I couldn't get this 60 and 61. I mean, why 61 for black? It's just model thing? Or because of the old data? I mean, is it some biasing or not?
Well, they're both about 60, right? So, so if you take the model, the results of the model, and it predicted that somebody was high risk. If it predicted that somebody was high risk and they're white, it was right about 60% of the time. And if it predicted that they reoffended and they were black, it was right about 61% of the time. Okay. So according to North Point, this is fair. Okay, I see Javier and Karina. So Javier?
But then there is also the possibility that the sample is, I don't know, 90% black people, and then it's putting a lot more black people in worse sentences than for white people.
Oh,
according to the sample.
Somebody was paying attention to our Bayes theorem lecture yesterday. Thank you. Karina?
Yeah, actually, I already knew the answer. Just forgot to put down my hand, but yeah.
Okay. Javier, you still want to say something, or you forgot to put down your hand? Okay.
No, I just forgot, sorry.
Okay. Well, how many of you think this is fair? Like, if you take the high risk category, the same, it was correct, the same percentage of time for black or for white. So is that fair? How many of you think that's fair? What about just putting up your hand if you think this is a fair definition? Okay. So now let's see what North Point found out. North Point used this definition: equalized odds. All groups have the same false prediction rate. And ProPublica says, wait, this model is unfair because among defendants who ultimately did not reoffend, blacks were more than twice as likely as whites to be classified as medium or high risk. So if you take all the low risk people and you look at the percentage of low risk people who get a wrong prediction out of the model, so who are wrongly predicted to be high risk, among the black defendants, that wrong rate was 42%. Among whites, that wrong rate was only 22%. So does that make the algorithm unfair? Who's right? So who says ProPublica is right?
Although I would have to ask, I don't get why these numbers are so far apart. Because it's really a big difference when being in the other case 60% is surprising to me. Unless medium and low are considered in the same group somehow, and then maybe it makes more sense. But
yeah. So I see there were about 5 or 6 of you who raised your hand for this one. So then would you accept a model that for every risk group had a different rate of being correct? So say if it predicted someone was high risk among the black population, it was correct 60% of the time, but among the white population, it was correct only 40% of the time. Would you see that as fair if that meant if it meant this thing would hold? Would you still put up your hand? And so the true problem, actually lies here. And this maybe will answer your question, Javier, as well. The true problem lies in the fact that the overall recidivism rate for Black defendants is quite a bit higher than for white defendants. It's 52% for Black defendants versus 39% for white defendants. Okay, so if you go back to this slide, it says when you have the proportion of high-risk individuals in one population is different from the proportion of high-risk individuals in another one, then you can't have both equalized odds and predictive parity. It's not possible. And the further the two numbers apart, the more one of the two fairness definitions will fail. So what's the problem here? Do we really have to make a choice? Can you think of some suggestions?
Yeah, it shouldn't be actually linked to the race, more or less. It should be an individual-based decision, not based like the decision in this case. I mean, race was not even a factor that was included, but then actually, I think it was coming back to the demographics and other factors where you could define whether the individual was Black or white. Mm-hmm. But I think that the race should not actually be a factor in the decision.
It's actually not, okay? So North Point will not release their model. And this is actually something we should think about when models are used to make such important decisions. We allow this to be done through private companies with proprietary models where you're not allowed to look inside and see how they're working. This is absolutely something, this is not a problem of the engineers. This is not a problem of the people who are writing the algorithms. This is our social problem that we're allowing this to happen. But the second thing is, the one thing we do know is that race is not one of the features that is used by the model to make its predictions. However, it uses 137 different kinds of features, and a lot of those features are correlated with race. Your income, your prior convictions, it asks you things about your family life. All of those end up being highly correlated with race, so that even though race has been taken out as an actual feature, the decision is made on attributes which correlate with race. And that's why we have this discrepancy. Can anybody see other problems with this model?
But Rania, sorry, one thing with North Point, didn't they say in the court case that they don't know themselves how the decision is taken?
Yeah, they you know, this is the beauty of black box models, but they do know what features they've dumped into.
Yeah.
Yeah. And even that is something that is hard for somebody who find out. So there is something else wrong with this model. And aside from the fact that it's proprietary, it's that it doesn't work well. it's a really bad model. And if you look at this second article, I highly recommend it. What they show is that this model is no better than taking random people off the street, totally untrained, telling them information about the defendant without telling them the race, and then having them decide whether this person is going to reoffend or not. Okay? So what we're doing here is we've taken a decision out of the hands of people who are supposed to be expert. We've put it into a model. This model claims to be expert. It claims to be unbiased because, of course, it's mathematics and computer code. And in fact, it doesn't perform any better than you or me guessing. So, do we really want to be doing this? Especially when using a model then means we have to choose what kind of fairness we want. Predictive parity.
Just a question. Isn't this study also mentioned? So, what is the difference with an expert group? So, an expert group made a different decision and more accurate than an expert or non-expert people. So we have the model, we have the non-expert people. Is this also tested on expert professionals in this?
This is a great question. I don't know. I only know that they tested it. Actually, this article only tested it on random people. And of course, it would be good to know whether experts do a better job at predicting things. If they don't, then this is something to be concerned about on a larger scale, on a societal level.
But in my opinion, maybe because the government employ the people who are working closely with prisoners, they can be considered as an expert than the person who is walking on the road. I mean, it will be better than a random person. I think so. As an expert, if there is a difference between who can be expert and who can be an expert person as a human. I think so.
Hello?
Gabrielle? Yes, we can hear you.
Okay.
Yes.
Well, my connection just sort of died. Gabriele, did you want to say something?
Yes, thank you, Rania. I think this is a problem with statistic, because we use models which are very good to predict the results for many people, but not for one specific man or woman. I think this is a problem we always have with statistic, and therefore, if we guess, will he be a problem, or is he a high risk for society? Yeah, it's a guess, because it's only one man we need to. We can only predict for a size of a group, for a big size of a group, but not for a specific one. And this is, I think, the problem with statistic, isn't it?
So when I say they made experts judge this, they made them judge a whole list of people. I think they made they made them judge about 100 people, and so out of those 100, what was the percent they got right? And it was pretty much the same as the model. So that's what I meant by the model is not better than people guessing.
Mm.
The other thing they showed in the same article is that even though the model uses 137 features, you can achieve the same sort of the same accuracy if you use a simple linear model, a simple linear regression, and use only 2 features. Festo.
Yes, maybe I could say if the performance of the humans were more or less equal to the model, it might mean there are some features that are really dominating this decision, because we highly think the humans are making consideration based on extremely few factors. So we could revisit the features that are dominating the decision of our prediction. Do we want these features to be the dominant decisive derivation for what we want? Because if these two are balancing, then certainly there is likeliness of some very dominant features that are taking this place. Yes.
Yes, very important point. Okay, Karina, I see you have your hand up, and then Diksha.
Yeah, I just wanted to say there is a super good TED Talk. I don't know if one of you knows it. It's called The Danger of Predictive Algorithms in Criminal Justice, Harry Farid. And actually, he reverse engineered the Compass algorithm, I think. And he compares it to the random judgment of people on the streets. And it's really like for me, it was quite mathematical talk. So I think it's a very interesting TED Talk to watch.
Yeah. So Hani Farid is the co-author of the second article I have here.
It's good. Yeah. So the TED Talk is very good. Like he really explains how he engineered, and then they just said, okay, it's so bad, let's ask random people, as you explained, and then it was the outcome was very bad. Yeah.
Yeah. So that's him. This is their article, and the TED Talk would be based on that. Thank you. Actually, do you want to, if you find the link, do you want to post it in the chat? So then
I can't post it. I found it, but it says chat. I cannot open the chat function, unfortunately.
Huh.
I can send it to you, and you can share it if you want.
Yeah. Oh.
Or you can send it to me also, Karina.
Okay, perfect.
Thank you.
Okay. I see here Diksha.
I just had an opinion with Festo about before you were discussing about this correlation, because things are so correlated. So at some point we also started deleting the features which are so correlated, so that it doesn't really affect our model to be biased. So I think this is also a solution to delete to this correlation factor, because of that this biasing is happening. I mean, this is my view.
Hello.
Hi.
Hi, Iris here. I was thinking like this model takes in consideration demographics of each individual.
It doesn't. It does not. It does not explicitly take race into account. The problem is it's correlated.
Features, yeah, but features are based only on demographics, aren't they?
No, it has all sorts of features.
Okay.
It has 137 features. So some of it is demographic, and of course some of it has to do with prior arrests and criminal record and stuff like that.
Okay.
Mm-hmm. Sarah. Sarah, you have your hand up?
Yes, I couldn't unmute myself. Hi. So yes, I have a question, because it's a bit odd to see that the algorithm performs probably worse than an expert, right? If it performs like a random guess of a person, probably an expert would do it better. And my question is if there are regulations about when to use an algorithm, or when can it replace decisions from people or stuff like that.
Excellent question. So in the US, clearly there is not. Okay, I have to go back to, here we are. Okay, in the US there is not. In the EU, we're working on it. And exactly what's going to come out of these deliberations, it's really not 100% clear. Maybe some of you who are more familiar with the law can correct me, but the closest I know that we come to a regulation about decisions being made about humans, and humans having the right to be judged instead by other humans, is in the GDPR. And the GDPR ruling is still a little vague and leaves some loopholes. So hopefully when we get around to actually implementing some stuff from the white paper, we will have a more stringent regulations, at least here in the EU. But it's a huge debate, and there is a lot of resistance also coming from the startup and the tech sector, because the debate is more regulation. A lot of people feel that will stifle innovation. Okay. Great. So how would you move forward from here? What is your solution? Is it regulation? Is it improving the algorithm? Is it not allowing algorithms for these kinds of decisions? Now I just gave away my answer, sorry. What would you do about this? Karina, you still have your hand?
Yeah, I think I very much agree with you. So I think we need regulation, and especially also with the part that if we do not know how a system works and there is no way to look into it, then we should, and we don't know where the decision comes from, then we should not use it to make decisions about lives of individuals that can have such a great impact. I think if an algorithm is used and we don't know how it works for something that cannot impact the life of a person, and it cannot lead to discrimination, then eventually it can be acceptable. but I don't think it can be accepted when it has an impact on an individual.
Gabriele?
Yeah, I think some decisions of people are always not objectives. They are very subjective too, as it is maybe from a system. But normally you should see what why the decision was being made from the algorithm, and it would be perfect if humans and algorithm came to an decision together, even if it's impact for humans, or especially when it impacts human autonomy.
I also think that what Gabi said is, so I personally think that it's very hard to get bias out of a biased person. And every human being has bias in themselves, like based on their experience. So also every judge. And I think these systems also show us how bad partly the historic decisions were that new decisions are based on. And we can take it as a chance to analyze how decisions were taken in the past and try to find ways to make better decisions in the future. But as Gabi said, I think it should be maybe in a way recommended that doesn't never give like a final decision, but rather shows some maybe statistics, but the decision has to be made on the individual case and not linked to at least that's what I think in the Compass case, and also in HR decisions and in loan decisions and many more. It cannot be linked to the statistics only. So yeah.
Absolutely. So I agree with both of you. First of all, humans do make biased decisions, and this is why we've ended up with all this data, which is full of bias. And part of the solution is possibly that we require both humans and models to explain to us and justify the decisions that they have made. Sarah.
Yeah, so I wanted to add something to it, because as we were seeing yesterday, in a way, any algorithm that we are going to build is based on biased data, and it has its limitations, right? So I guess it would be very important and a good practice to always report on it and reflect on it. Like, okay, this is the algorithm and these are the limitations, and it's safe to use it in this context. And I think that would be very important too.
Yes, absolutely.
Yeah, and just complementing what Sarah has said. Sorry. And just complementing what Sarah just said. I think it's there's always room to improve the algorithms, of course, and as you said, the company is reluctant to open the details of how the model is built, which are the features, but that's where I think the law came in and trying to interfere in this. I don't mean just open to everyone, but maybe some kind of audit to check what they're doing, maybe.
Just also to add to this, I agree. I think there should be, I mean, depending on, I mean, at least a court should be able to audit. There should be, or to ask to require a company to open up their systems. And then there could be like commissions like looking into it. But in the case that it's such important decisions, such as like in the criminal procedures, where the state has the power over the individual, really affecting the life using private software that is based on making a revenue on it. I think there should be standards, and maybe it shouldn't be provided by a private company in this sense, and it should be open to see what the factors are that you're being evaluated on. Yeah.
Great. Okay. Iago?
And maybe why I'm sorry.
Go on, Rodrigo. Finish. Sorry.
Okay. And why not a second opinion? We do this all the time. When we go to a doctor and we're not convinced what we hear from the doctor, we go to another doctor to ask a second opinion. Why not use a second algorithm and not based just in only one? Maybe hire another company to do the same thing and see what.
Mm-hmm.
Yeah, so just to add, I'm still thinking about that it performs or equal to random people, but I wonder why we assume that random people made a bad decision. In fact, when precisely in the US, the judiciary system is based on jury, on a jury of peers. So people taken from the street that they actually decide if you go to prison in the first time or not. I mean, anyway, a human is collecting information through their whole life. So when they see this data, it might be biased, but if you take a lot of people, it would correct. So maybe assuming that random people is a bad choice, I perhaps don't agree with this thought.
That's a very good point. I neglected to tell you that the overall accuracy of this model is around 65%. So
that's
it gets 35% of its predictions wrong. I don't know about you, but when it comes to something as important about whether someone should go to jail or not, I would expect the model to perform better. If all it has to do is recommend to me the movie I'm supposed to watch next, I can accept 65%. But yeah, I didn't give you that information. So, Diksha.
Yeah, I just had was agree with Iago, but I also had this, that what happens when a human also, I mean, we don't want model, we want some human opinions also, but sometimes humans are much more biased than machine, I mean, than a model, because of they have their own personal things also. So I think, I mean, that's not also sometimes good idea to always not take the model and always go for human opinions, because they are much, at least model is like we can work on it and we can make it better, but we cannot do this thing with a human. So this makes thing, I mean, I am living in India, I know if there is nothing like this, then people get, there are so many criminals who just get this, they get free. So I think it's a nice thing to have a model on the basis of what you want to convict someone, high risk or low risk. I mean, this is totally my opinion. Yeah.
Yeah, that's true. We can think about the fact that a model, at least you have a chance to fix it. You can tell it what to do. Karina?
Yeah, I just wanted to add that there is a lot of criticism about the jury systems also, and that actually there are a lot of concerns about the jury systems. And I think that the dimension which is very important is that historically we are used to having judges and independent individuals who are supposed to be non-biased, although it's not possible, to take our decisions about our lives. So it's something that we, as societies, just got actually we work in the system and everybody accepts it. And so I think to have this new factor of a machine in the loop is something that is very, I mean, it's the same with, or for me, placative example in this case is the self-driving cars, where you would accept the risk of driving a car because it really brings a benefit to society. And then if something bad happens, you just as an individual take a decision, and we accept that this decision might be wrong and you don't even go to jail because you were under shock and stress. But now you need to define certain collateral damages beforehand. So you need to think beforehand which turn a car should make in situation ABC. And it's something that is something that humanity has not defined so far as where the correct answer lies. And I think you cannot generalize it. And but I think that the interplay of machine and human will be very helpful also to make better decisions, in the sense that you cannot just take, I mean, now you have instances, so even if a bad decision is taken, you can complain and go to the next instance, and you just need to trust that a set of judges takes better decisions than the one in the first instance if you're not happy. And in this case, it could be a new factor of better decision making. But I think still you want to know if you're convicted based on which factors you have been sent to jail.
Yeah. So let me summarize here what I think I'm hearing, and if I missed somebody's point, please tell me. So one factor that's coming out very loud and clear is that well, we humans ourselves are flawed and biased. So what makes us think that the human decision would be better? And in terms of the model, what we have is, first of all, check the data. The data is biased because of us humans. The second point is that we want our models to be able to explain things, that there should be a justification for decisions made, that we want audits on the algorithms. So it's not okay that these things are private and hidden inside a black box. We should be able to check what's going on by an independent third party, especially on algorithms that impact so heavily, such as the criminal system. And we have a suggestion of a second opinion, so it shouldn't all come out of just one algorithm, but maybe you have two models, or one model and one independent human opinion. Are there other suggestions? How do we deal with this problem? Did I miss something on my list?
Like maybe also regulation. I also wanted to add that, sorry for talking so much. I wanted to add that I think regulation can also give a certain framework that shows you how to operate. And this is a certain freedom that you might get as a company if you are if you know what is allowed and what is not allowed and what is okay and what not. It can also bring opportunities. So I am personally in favor of not over-regulating everything, but having standards guaranteeing that certain freedoms and rights we have fought for are guaranteed. And I think it can be also in line with what companies want, because they want to operate in a safe space, and that's why they like why it's good to have open companies in Europe, because you know the laws, the regulation, and it's a very clear, defined environment where you're operating in. So it can be an advantage.
Yes, absolutely. I want to bring it back to one question, which is this. So nobody has suggested completely getting rid of models, which means that we do still have models. We still want to be able to use them. And if we use them, we still need to figure out, to measure somehow, are they fair or are they not? So I want to go a little bit into the detail now. If you're building a model and you have to check if your model is fair, what definition of fair are you going to use? And who gets to decide that? Are you going to leave this decision up to the machine learning engineer? Because I'm just saying, you leave the decision of what's fair up to the engineer. You leave the decision of which groups to look at. So which ones are protected, which ones are unprotected. You're leaving this also to the engineer. What is this engineer? Somebody who is a jack of all trades, and you know, I know that they're very smart, but can they really do all of that? So Diksha and Sarah?
I was wondering regarding this matter that if there are some rules some countries take, so there is like United Nations. I mean, there is a whole international level, like people who takes care of that. You don't have like what you call destroy the human rights. You don't overtake it. So there is always some people who takes care of. So why not in the data analysis we also have some people who takes care of such thing? I mean, they have their own that okay, this is not the definition of fair, rather than giving to any engineer and he takes care of these things and he makes his own definition of fair and they work on it. So yeah.
Yes, Sarah?
Thanks, Rania. So I would like to do an analogy with evolutionary biology because I think we can learn from nature. and the idea is the following. So we have a variety of bacteria and viruses and different animals and species that optimize for different things, right? You different strategies in different environments. So I don't think we can have one definition of fairness, but I think it is rather bounded to the definitions of fairness should be defined in the context in which the algorithm is going to be applied. Because we have so many different situations that we can probably not optimize for all of them with one single number, right? Mm-hmm. So I think we could have an ecosystem of algorithms and of criteria of fairness and choose the one that fits the best in different. That's an idea, probably a bit out of the box, but yeah, maybe something that we can think about.
Yes, and in your system, who chooses?
Well, maybe we can take the idea that Diksha was proposing, like a person that is a specialist on the area of matching these two things. But for the moment, I think the person who is developing the algorithm is the one that is going to choose it, right? I mean, we don't have right now a system, so we have to do it.
So right now, yes, that is absolutely the situation we have. But now I want you to take a step back and think, all the examples of bias I gave at the beginning of the talk. So yeah, looking here and moving back. Who is impacted by these? Which groups suffered?
The people who were supposed to release, but they couldn't.
Yeah.
Because the most vulnerable people.
Yeah.
Minorities, no? Minorities.
Minorities, okay? And women. I don't think women are a minority, actually. I don't like when women get lumped with minorities. We're half the world's population. But so who's usually on the receiving end of bad algorithms? It's women or it's minorities. Now think about who are the people making the algorithms in general. Okay, just think. What's the first pronoun that comes into your head when you think engineer?
He.
He. Okay, and you know, is there sort of a typical machine learning engineer, the stereotypical one? If you Google it and you get pictures back, what pictures do you get?
Normally white men.
Very good. So we have a problem, and that problem is that there are certain people who are disadvantaged. Why are we expecting the solution to come from technology when technology is run by exactly the same people who are not disadvantaged? Okay, so we have a problem in technology itself, that it's not fair or it's not fairly distributed. Not everybody who could be is involved in the creation of technology. So I just want to end. Okay, where is it? Here. Okay. So we really shouldn't wait for technology to fix our problems. It's up to us. And so this is a call to action, people. We have some great ideas here. Anybody who wants to work on this with me, I am very interested in finding ways to fix things. And I invite you all to get in touch with me. We have some great ideas. I took them down here. And if you have more questions, I'm happy to stick around. So thank you very much for participating. I had fun. I hope you did too.
Yes, it was very interesting.
Thank you very much.
Thank you, Rania. It was great. Thank you.
Listen.
Thank you.
Thank you. Very cool.
So, yeah, if anybody has more questions, just let me know. Otherwise, I guess for my class, I'll see you later. And for everybody else, hope to see you soon again sometime.
I just wanted to add something briefly. I think that one issue is that there are by now so many NGOs and advocacy for many groups of the society. But the problem is really, sorry, that, sorry, I'm losing my voice, that many of those I realized they feel very far away from everything that is programming and algorithmic, and it seems like a very far away topic that they cannot grasp. And what I realized, like sometimes asking people to join in, for example, Women in AI or give a talk, they refrained, although they are super established human rights institutions, because they were afraid of not being able to discuss on a level that is that shows that they have expertise. So I really think that there's a lot to be done in educating or sharing knowledge with human rights organizations and NGOs who are already fighting for underrepresented groups and people or human beings who don't have as much voice as the majorities.
Yes, absolutely. You're right. And that is a barrier that we need to figure out how to break down. Which, by the way, anybody who likes to work on projects for NGOs for good, we have Data for Good, and that's part of our mission to do stuff for NGOs so that they also learn what data science and machine learning is at a technical level, so that they do feel comfortable talking about it.